Okay. Okay, sir. We already seen that single rotor system and double rotor system. All these things we already seen. Just giving the glance about that. Okay, and this is called a single rotor because the one end is on a fix. The another one is having the rotors. This point B is having the rotors. Okay, this is called a single rotor system. For this node system, it will be like this. Okay, it will be starting point. From this point is a minimum one, and the end of the rotor is a maximum one. This is a node A. Okay, to a portion of node A, and this is called single rotor system. For this, the formula will be given as Fn equal to 1 by 2 pi square root of Q by I. Okay, this is a formula for a single rotor system. Just we already seen, so I am just go through all these things. Okay. And next one is called a two rotor system, and this is a diagram for a two rotor system. Two ends is without a fixed end. There's a two ends. Okay, the two ends is having the rotors. Okay, rotor A and rotor B. Okay, the two rotors will be there. Okay, that will we call it as a two rotor system. Here Fn A, rotor of A and a rotor of B. The frequency of A is equal to frequency of B. Okay, and this is called a node diagram, and the bottom one is having the node diagram. This one. Okay, in this diagram, this is a minimum position, a maximum position in both the sides. Okay, both the position, both the ends is not the same. According to that, frequency varies. It will be also varies. Okay, it's not in the center point. Okay, it will be varies somewhere else. Plus or minus here from this center point. Okay, because of the weight conditions and the speed conditions, it will be vary based on the applications. It will be vary there. Okay, and this is called a two rotor system. And this is a formula. Listen, man. Now the formulas are very clear now. Yesterday the values of pi is missing. Okay, today it will be clear. Okay, pi and the plus value. This plus value is all missing yesterday. Okay, I correct it now. Okay, that is called 1 by 2 pi square root of C by J LA into IA. That is equal to Fn of B. Fn of A equal to Fn of B. Okay, this line. Okay, so 1 by 2 pi Cj La into Ia, that is same as like 1 by 2 pi square root of Cj Lb into Ib. Is nothing cancelling of all the common terms here. La into Ia, that is equal to Lb into Ib. Okay, and their La equal to Lb into Ib, Lb into Ib divided by Ia. Okay, and one more term is called L is nothing but of La plus Lb. Okay, this is data based on the two rotor system. Okay, next we move on. Make a note of these formulas. I already seen the shown the formulas to you. Once again, it will be corrected formulas. Okay, yesterday the pi value is missed in that slides. Okay, due to technical issues. Okay, the pi values are missed. Now it will be very clear. Make a note of it. All the formulas. Okay. Yeah, this one frequency of A, first line, and second line is called frequency of B, and the third one is equal to this one, and fourth one. Make a note of all the formulas. Okay, and we move on to the next line now. Yeah, and this is called as a three rotor system. In the three rotor system, I already shown this diagram to you. Okay, this is a rotor of A and a rotor of B and a rotor of a C. Okay, from A to B, this length is called L1, and B to C length equal to L2. Okay. For this, there is a node system. It will be followed here. Okay. Here it is called a two node system. This system is called this node system is called a two node system because there is called an N1 and there is a N2. So we call it as a two node system. This is, and the same one node system is also followed for the three rotor system. Okay. Yeah, make a note of this formulas. Fn of A equal to 1 by 2 pi square root of Cj La into Ia. This formula. Okay, in front of your screen. These formulas. Okay, and Fn of B is totally different. Okay, Fn of B equal to 1 by 2 pi square root of Cj by Ib into 1 by L1 minus LA plus 1 by L2 minus LC. Look it out here. This is called 1. It's not a L here. These two things are L. Okay. Make a note of these formulas also. This is also one of the important formulas. Okay. And next one is called frequency of C for a rotor C, that is equal to 1 by 2 pi square root of Cj by Lc into Ic. So you're getting 2 and 3 and 3 all the formulas. Okay. You're getting 2 and 3. F1 of A equal to F1 of B equal to F1 of C. F1 is nothing but of a frequency of A, frequency of B and frequency of C. Okay. Both three things are same because the frequency doesn't changes for the single shaft. Okay. So the frequency of A, frequency of B and frequency of C are same. Okay. Equating that. Okay. First initially they are equating 1 and 3. The first formula for a frequency of A and frequency of C equating 2 and 3 here. We get it LA equal to LC into IC divided by IA. Okay. And next one is called equating 2 and 3 now. 2 and 3. This line. Okay. That is 1 by 2 pi square root of Cj into IB into 1 by L1 minus LA plus 1 by L2 minus LC. Okay. Writing this formula, we can get that like this. So total stiffness, torsional stiffness of L1 minus LA equal to this one.
Sir, not straight conveying, sir.
Okay. Yeah, make a note of it, man. இந்த மைனஸ் இந்த பையோட வேல்யூ கீழே வரணும், பையன்றது கீழே வரணும், மேல போயிட்டு இருக்கு கொஞ்சம். அதே மாதிரி L1 minus of LA and L2 minus of LC here. Yeah, shall I move on the next slide now?
Yes, sir.
Okay, thank you. Yeah, these are the formulas and continuation of the formulas. Torsion stiffness due to L1 minus of LA equal to Cj by L1 minus LA and L2 minus LC equal to Cj by L2 minus LC. Okay, therefore total stiffness of rotor B equal to Cj 1 by L1 minus LA into 1 by L2 minus of LC. Okay. Next slide. Yeah, this is called just I already told that single node system. Okay, for 3 rotors. Okay, A, B and C, 3 rotors will be there. There's a length will be given as L1 and L2. Okay, for this single node system, what we seen already in the initial, this one is called a 2 node system. Okay, 2 nodes will be there, node 1 and node 2. Okay, this is called 2 node system. Okay, the problems will be also in the both regions. Okay, 2 node system as well as in the single node system. Okay, and this is called a single node system. There is only one node it will be there. Okay, okay, maximum position, minimum position and maximum position of nodes. Okay, we call it as A1, A2 and A3. 3 areas. Area will be taken as A1, A2 and A3. It must be like this or like this. Okay, vice versa. Both the things it will be possible. Both the things also correct. Okay, both the node system is correct. It's called whether it will be goes on increasing or goes on decreasing based on the data. Okay, and this is called single node system. Okay, and this is an A1, A2 and A3 calculations. Okay, amplitude of vibration of rotor A is known as amplitude of rotor B. Okay, like that A2 and A3 will be given. This is a thing, it will be very clear for you while solving the problems. Okay. Yeah, next to one more main topic, it's called torsionally equivalent shaft. Okay, what we've seen already up to a single rotor, two rotor, and three rotor system, all the shafts are equal diameters. What? All the diameters are equal diameters. There is no change in diameters. Okay, the shaft diameter, I call it as a shaft diameter, and not, I am not talking about the rotor here. Okay, shaft diameter, all the shaft is having the same diameter from start to end point. For example, diameter of the shaft is 50 mm, means one end is 50 mm, another end is also 50 mm, in middle of them is the same 50 mm. But in this case, as in some applications, what will be happens, the diameter of the shaft, it's not in the same. Okay, it will be vary. Sometimes it will be stepped shaft. Sometimes it will be an what we call a cone shaped, it will be there. Okay, like that it will be changes. Okay, for that we know that first of all we want to convert into torsionally equivalent shaft. Yeah, for example, yeah, given in the two diagrams here, look at it here, what we seen in the single rotor, two rotor, and three rotors, the first diagram, this will be like this. Okay, diameter 1 and 2, throughout the sum it will be same. Okay, but in the case of stepped shaft, for example, that look at the diagram number 2 here. Okay, this is called a stepped shaft. Okay, here is a diameter, for example, the diameter is 20 mm here, and here is a 40 mm, and here is a 30 mm. So there's a change in diameter of a shaft. Okay, so for this you want to first of all convert into torsionally equivalent shaft. Okay, like this. You want to convert this shaft into like this. Okay, that is called torsionally equivalent shaft. Okay, it will be the same thing, it will be given in a theory part here. Consider a shaft of varying diameter as shown in the figure A. Okay, later the shaft is replaced by an equivalent shaft or uniform diameter shaft D. Look at the line here. The shaft is replaced by an equivalent shaft of uniform diameter D and length L as shown in figure B. This thing. These two shafts must be the same total angle of twist when equal and opposite torques are applied to the opposite ends. The torque doesn't changes here. Only thing it will be changes is called the diameter of the shaft. So the diameter of the shaft will be changes means the length of the shaft is also changes. That's the thing, it will be given in the theory part. Okay. The given diagram, it will be like this. You want to convert into like this here. Given one, this one, the shaft of varying diameters. Okay, you want to convert into torsionally equivalent shaft like this. Are you clear, man?
Yes, sir.
Okay. So these are the data it will be used: D1, D2, D3, diameter of first point, second point, and third point. Okay, same as like L1, L2, and L3, J1, J2, J3, and theta 1, theta 2, theta 3. All these things will be taken into account. Okay. In actual calculation, it is assumed that the diameters D of the equivalent shaft is equal to one of the diameter. Okay, நம்ம என்னன்னு எடுத்துக்க போறோம் இப்போ first diameter it will be equal to D. Okay, that's a thing taken under here. D equal to D1. This D1 தான் வந்து assume பண்ணிக்க போறோம். D1. So instead of ஏதோ ஒரு diameter எடுக்கிறதுக்கு பதிலா we are taken as D1 as D here. Okay, this D1 as D. Okay. So for that the formula it will be like this. Okay. Yeah, by using of derivation of all these things. Okay. T by T into L by T into L divided by C into J. Okay, that's T into L1 divided by C into J1 plus T into L2 divided by C into J2 plus T into L3 divided by C into J3, like this. Okay, so T and C will be in a common. So L1 and J1 will be vary here. So that is L by J equal to L1 by J1 plus L2 by J2 plus L3 by J3. J is called polar modulus, L is called length of the shaft. Okay, that's taken into account. That is L divided by pi by 32 d power 4. Okay, that is L1 divided by pi by 32 into d1 power 4, like that it will be continuous. So again that same terms it will get cancelled. So pi by 32 will get cancelled here. 1 by d power 4 plus that is equal to 1 by L1 by d1 power 4 plus L2 by d2 to the power of 4 plus L3 divided by d3 to the power of 4. That's the thing, it will be written here. Okay, here rearranging of all these things. L is nothing but of the total length of the shaft. L equal to L1 plus L2 d1 by d2 to the power of 4 plus L3 into d1 by d3 to the power of 4. So L is nothing but of an length of an equivalent shaft. Okay, once after converting this diagram into like this means you want to call it as an torsionally equivalent shaft. புரியுதா? இப்படியும் கொடுத்திருக்கலாம், ஸ்டெப்டு ஷாஃப்டாவும் கொடுத்திருக்கலாம், இல்ல angled ஷாஃப்டாவும் கொடுத்திருக்கலாம். Okay, one end is in a 50 mm, the another end is in a 20 mm, means it will be like in a cone shape. Okay, that is also possible in a torsionally equivalent shaft. So make a note of this formula. This is a very, very important formula for converting torsionally equivalent shaft into stepped shaft into torsionally equivalent shaft. Okay, make a note of this formula, this line, what the thing I am highlighting here. I think I am going very slowly today. Whether it will be okay for you? Are you following?
Yes, sir.
Good. Okay, make a note of it, this formula. I'm move on to the next slide now. L equal to L1 plus L2 d1 by d2 to the power of 4 plus L3 into d1 by d3 to the power of 4. எல்லாமே in terms of d1 ல எடுத்து வந்திருக்காங்க. புரியுதா? L1 plus L2 d1 by d2. Okay, plus L3 into d1 by d3 again. Okay, in terms of d1 ல எல்லாத்தையும் கொண்டு வந்திருக்காங்க. Okay, the sum based on the torsionally equivalent shaft. Okay, a steel shaft of 1.5 meter long. For this also you want to draw one small rough diagram. Okay, whether it will be given or not, it's not an issue here. Okay, you must draw the single diagram. Okay, single reference diagram. Okay, that's not mandatory here, but it will be useful for your calculation purposes only. Okay, it will be represented, means it will be give the good marks for you. Okay, that is all. That's all. Okay, a steel shaft of 1.5 meter long is 95 mm in diameter for the first 0.6 meter. Okay, of its length, 60 mm diameter for the next 0.5 meters of the length, and 50 mm in diameter for the remaining 0.4 meter of its length. The shaft carries two flywheels at two ends. Okay, so then it is called a two rotor system. Okay, the first having a mass of 900 kg and 0.85 radius of gyration located at 95 mm diameter end, and the second is having a mass of 700 kg and 0.5 meter end located at another end. Determine the location of node and natural frequency of free torsional vibration of the system. The modulus of rigidity equal to 80 giganewton. The modulus of rigidity is not given, means you want to take in as an 80 giganewton. Okay, most of the problems it will be given. Once it's not given, means you can take in as an 80 giganewton per meter square. That is 80 into 10 power 9 Newton per meter square. While you're taking like that, means you must given a clear note about that, assuming that G value. Okay, assuming the C value as 80, like that you want to mention. Okay, so for this I want to draw a smaller diagram like this. Okay, this is a diagram. First 95 mm for the 0.6 meters. Look it out here, 95 mm diameter and a 0.6 meters length. Okay, next one is called 60 mm and 0.5 meters of length, and last one is 50 mm, 0.4 meters length. Okay, and the two rotors at both ends சொல்லிருக்காங்க, A and B னு rotors பிரிச்சிருக்கோம். Okay, kind of data need to be given here. Mass of A equal to 900, K equal to 0.85. Mass of A, mass of rotor A. Radius of gyration for rotor A is 0.85 meters. Same as like mass of rotor B, it will be given. Mass of rotor B will be given, and radius of gyration of B is also given as 0.55. Okay, look at the diagram. Go through the sum first of all for a moment, and then I shown the diagram for you. Study the problem once again, and wait a moment. I'll show the diagrams for you. Okay, look at the diagrams. So total length will be given as on 1.5 meter, that will be mentioned here. Okay, this is a given diagram. Okay, for the given data we drawn one diagram, that is called this. Okay, there is no need of any scale, all things. Okay, just a diagram is enough. Okay, no need of an exact scale like that. Okay. Okay, now we go for solving of this. Okay, yeah, first you want to, I already told in the torsional equivalent shaft itself, first you want to convert the stepped shaft into torsional equivalent shaft. Okay, that's the first step. Okay, that's the first step. Okay, length of an equivalent shaft, you want to convert the length of the equivalent shaft. So L equal to L1 plus L2 plus L2 d1 by d2 to the power of 4 plus L3 d1 by d3 to the power of 4. Okay, இது வந்து whole power ma, d1 by d2 to the power of 4. Okay, d1 to the power of 4 கிடையாது, d1 by d2 to the power of 4. Okay, அதே மாதிரி தான் இங்க same as like this, d1 by d3 to the power of 4. Okay, d1 க்கு மட்டும் 4 போட்டுறக்கூடாது, போட்டீங்கன்னா தப்பாயிடும், சம்ம தப்பாயிடும். Okay, length வந்து கொடுத்திருக்கு நம்மளுக்கு. First வந்து yeah, Surya, tell me that.
எது மேக்ஸிமம் டயாமீட்டரோ அதானே சார் d1 கன்சிடர் பண்ணுவோம், அப்பதானே இந்த ஃபார்முலா கரெக்ட்டா வரும்.
மேக்ஸிமம்ன்றது தேவையில்ல, ஃபர்ஸ்ட்ல இருக்குது டயகிராம்ல, ஃபர்ஸ்ட்ல இருக்குது
சார். இல்ல சார், இப்போ இந்த சம் எடுத்துக்கோங்களேன், இதுல வந்து 95 mm இருக்கு. இத வந்து டார்ஷனலி ஈக்குவலண்டா கன்வெர்ட் பண்ணனும்னா மொத்தத்தையும் வந்து 95 mm கீழ மாத்திப்பாங்களா?
ஆமா ஆமா ஆமா.
அதே மாதிரி அப்போ எது மேக்ஸிமமா இருக்கோ அதோட தானே அவங்க கன்வெர்ட் பண்ணுவாங்க. அப்ப எது
மேக்ஸிமமா இருக்கிறது கிடையாதுப்பா. இந்த d1 will be taken as d. புரியுதா? அத இந்த டயகிராம் முன்னாடி காட்டுறேன் பாரு உங்களுக்கு. Look it out here. d equal to d1 கொடுத்திருக்காங்க.
ஓகே சார்.
இந்த டயகிராம்ல தோ கொடுத்திருக்கு பாரு. d1 equal to d. ஓகே.
So whatever the diameter may be, first இருக்கிறது தான் d ன்னு எடுத்துக்கணும்.
ஆமா ஆமா. Okay, correct. That's correct. Okay. Okay ma. Yeah, solving this, that is 0.6, length on L1 equal to 0.6 and L2 equal to 0.5. D1 kana diameter 95, convert into meters here, 0.095 meters, and 60, D2 equal to 60 mm, that is 0.06, plus L3 value into D1 value 95 mm, that is 0.095 meters, and 50 mm, that is 0.05 meters to the power of 4. Okay, put together the L value is 8.95 meters. So the length of an equivalent shaft equal to 8.95 meters. Okay, next one, you want to find out the location of node. Two things they asked in the question. Okay, first you want to find out the location of the node. Second, you want to find out the frequency of an rotors. Frequency of an rotors. Okay, two rotors, because that two rotors only given. Okay, so for that, first you want to find out the location of a node. Okay, so first we have to find out the IA, mass moment of inertia. I equal to mk square, mass into k square. Okay, that is same as like an I of B, I of A and I of B. Finding of two things, 650 kg per meter square and 212 kg meter square. Okay, and then it comes the formula here, LA into IA equal to LB into IB. The two rotor system itself, we seen this formula. Okay, LA into IA, that is equal to LB into IB. Solving using this, you get the value of LA in terms of LB, because LA value, LB value is unknown value. Okay, that's the thing you want to find out here. Okay, that's the thing you want to find out. Okay, so LA in terms of LB, you get the value. LA equal to 0.326 of LB value. Okay, and one more term, you know that L is nothing but of LA plus LB. L is nothing but of LA plus LB. Okay, already we find the L value as 8.95 meters here. Look at the screen here, L already find out, that is 8.95 meters. So this L value. So put the 8.59 meters here. LA already in terms of LB, you get the values 0.326 LB. So put the value here. Instead of an LA, you are putting 0.326 of LB plus LB, that is equal to 8.95. Okay, value. So cross multiplying of all these things, we get the value of LB equal to 6.75 meters LB, and then you can find out the LA value as 2.2 meters. So LA term equal to 2.2 meters. L from rotor A to node position is 2.2 meters. From rotor B position to middle of the node value is called 6.75 meters. Okay, that's the two terms. We shown in the diagram also. That's the same thing. Okay, the same thing it will be given here. And the node, it lies at 2.2 meters from flywheel A or 6.75 meters. Okay, both the things are correct. Okay, or look it out here, it will be given as R. Okay, 6.75 meters from flywheel B on a equivalent shaft. So position of node on the original shaft. Okay, இது வந்து இந்த ஷாஃப்ட்க்கு முடிஞ்சிச்சு. This is called an equivalent shaft. Okay, you want to find out again the position of node on the original shaft from flywheel A. For that you use this formula, L1 plus LA plus L1 D2 by D1 to the power of 4. Okay, put this value, that's a value is called 0.855 meters from flywheel A, that is called an original position of the node from the original shaft. Okay, position of node on the original shaft. Okay, that will be given as 0.855 meters. Okay, and then second question is called natural frequency of free torsional vibration. So J polar modulus pi by 32 d power 4, you already find, you know this about this diagram, this value. Okay, and frequency of A or frequency of B, all these things will be same, and taken as a frequency of A 1 by 2 pi square root of Cj into La into Ia. Put it again, 1 by 2 pi into 80 into 10 power 9 plus J equal to into here 80 into 10 power 6 divided by La value is 2.2 and Ia equal to 650, value is 3.37 hertz. This is the thing, it's called, this is sum is called like this, the same model sum, it will be asked in the university. Okay, this will be carries a 13 mark sum. Okay, just go through once again. I put it from a first slide for you. Just go through, and one more thing is called, very few of them it will be submitted the assignments. Okay, less than 10. Okay, already 2 days is over posting the assignments. Okay, very few of them it will be submitted the assignment, because already we know that end of assignment is on this weekend. Okay, we know that, but very few of them it will be turned up. Okay, you can raise any questions based on that problem what we taught today, what we seen today. Do you have any doubts? Yeah, no, move on to the next slide now. சுரேஷ் சார், நீங்க ஏதாவது சொல்றதா சொல்லிடுங்க சார்.
இன்னைக்கு உங்களுக்கு ஸ்பெஷல் கிளாஸ் இருக்கு ராஜா. இப்போ அந்த ஸ்பெஷல் கிளாஸ் அந்த டீடைல்ஸ் எல்லாமே வந்து இப்போ உங்க குரூப்ல போஸ்ட் பண்ணிருக்கு. அந்த A and B section all together just we have identified 47 members. அவங்கெல்லாம் யாருன்னு பார்த்தீங்கன்னா இந்த டெஸ்ட்ல வந்து பிலோ ஆவரேஜ், அதுக்கப்புறம் வந்து ஆப்சென்டி ஸ்டூடெண்ட்ஸ். ஜஸ்ட் we have identified 47 of them. For them, just we have the special class by 12:30 to 1:15. Okay. See, attend positively because that too carries the marks. ஓகேவா? ஏன்னா இது ஸ்பெஷல் கிளாஸ் பண்ணா மட்டும்தான் உங்களுக்கு அந்த சைக்கிள் வந்து க்ளோஸ் ஆகும். அதனால பாசிட்டிவ்லி அட்டெண்ட் த ஸ்பெஷல் கிளாஸ். யாரும் வந்து வெளியில போயிடாதீங்க. ஏன்னா ஜஸ்ட் 12:30 to 1:15 தான், ஜஸ்ட் 45 minutes, நாட் மோர் தென் தட். சரியா? அதனால அதுக்கும் அட்டெண்டன்ஸ் இருக்கு. தட் டூ ஆல்சோ கேரிஸ் த மார்க்ஸ். இப்போ இந்த மார்க் ஃபெயில் ஆனவங்களுக்கு எல்லாருக்கும், இந்த ஆப்சென்டிஸ் ஆனவங்க எல்லாருக்கும் வந்து தி ஸ்பெஷல் கிளாஸ் வில் கிவ் த ஆடட் த பூஸ்டட் மார்க். அதனால கம்பல்சரிலி we request all the failures and absentee students to just actively participate in this special class activity. Clear? அதுக்கப்புறம் சார் சொன்ன மாதிரி பர்னி சார் said assignment வந்து just 7 to 10 members so far have uploaded. Just we have asked you to write only 2 questions. Okay, that too also based on the reference of previous year university question papers. Just we have formulated those questions. And the question மட்டும் தான் நாங்க கொடுத்திருக்கோம். Just it's matter of 45 minutes to completely finish it up the 2 questions. Clear? அதனால நாங்க வந்து அகைன் உங்ககிட்ட சொல்லணும்னு எதிர்பார்க்காதீங்க தயவு செய்து. This weekend is the deadline. Before Saturday, just try to upload the 2 questions with answers in your Google Classroom. In that platform itself, you will be given the marks based on your performance. Clear? Just two questions ஒரு அசைன்மெண்ட்டும் நான் உங்களுக்கு கொடுக்குறோம். அதனால கொஞ்சம் பாசிட்டிவா அதை அட்டென்ட் பண்ணிட்டு பிஃபோர் திஸ் வீக்கெண்ட் ஜஸ்ட் ட்ரை டு அப்லோட் தட் கொஸ்டின்ஸ். ஓகே.
யாராவது ஆப்சென்டிஸ் அண்ட் ஃபெயிலியர்ஸ்ன்றது உங்களுக்கு குரூப்ல போட்டிருக்கு. ஓகே, இந்த கிளாஸ் முடியறதுக்குள்ள இன்னொரு வாட்டி நான் ஷோ பண்றேன் அதையும். ஓகே, பிரசன்டேஷன்லயே ஸ்லோ பண்ணிடுறேன். எல்லாருமே வரணும். நேற்று பாத்தீங்கன்னா கிளாஸ்ல மோர் தென் 12 members will be absent for your special class. Okay, regular class it will be attendance வந்து பாத்தீங்கன்னா regular absentees or 2 or 3 members. Okay, that will be an exceptional case. Okay, that will be no issue there. Okay, in the special class பாத்தீங்கன்னா 12 members will be absent. Okay, out of 40 I think so yesterday. Okay, 12 members will be absent. Okay, இன்னைக்கு யாருமே absent ஆகக்கூடாது. Okay, regular classல எல்லாரும் கரெக்டா அட்டென்ட் பண்றீங்க. அப்புறம் what about the special class for you? Okay, இன்னைக்கு கண்டிப்பா எல்லாருமே அட்டென்ட் பண்ணணும். யாருமே ஆப்சென்ட் இருக்க கூடாது. I think next week you have another MCQ test. Next week maybe on Wednesday or Thursday your next MCQ will be started.
அதே மாதிரி இன்னொன்னு என்ன சொல்ல வரேன்னா, நீங்க இந்த MCQ வந்து ஒழுங்கா அட்டென்ட் பண்ணீங்க அப்படின்னா you need not to face out this kind of a special class activity. Since you have failed in that MCQ questions only, just we are asking you to just write we are asking you to come and attend this special class. So that's completely everything is in your hand. அதனால as Bharani sir said, next week வந்து coming week you may have the second set of that MCQ question test. See, during the test, just try to read out all the questions very thoroughly, because whatever the data are the related materials which we are posted out in your Google Classroom only. From that point only, just we have framed all set of the questions, that objective type of questions. So just read that all those documents very thoroughly. Okay, because you are having the abundant amount of the time. அதனால just read all the questions very thoroughly. அதை பேஸ் பண்ணி தான் உங்களுக்கு எல்லா கொஸ்டின்ஸுமே நாங்கள் MCQ வந்து கேட்டிருக்கோம். அதனால அதை ரீட் பண்ணிட்டு கொஞ்சம் தரவா வந்து கொஞ்சம் ஆன்சர் பண்ணிட்டு கொஞ்சம் நல்ல மார்க்ஸ் எடுக்கிற மாதிரி பாருங்க. We are expecting again in the consecutive the special class after which is going to happen the second MCQ. We don't want anyone to just as the participant from your class. உங்க கிளாஸ்ல இருந்து யாருமே வரக்கூடாதுன்னு நாங்க எதிர்பார்க்கிறோம். சரியா? அப்போ நீங்க இந்த MCQ வந்து நல்லா பண்ணணும். நல்லா பண்ணிட்டீங்க அப்படின்னா நீங்க யூ நீட் நாட் டு அட்டெண்ட் எனி சார்ட் ஆஃப் த ஸ்பெஷல் கிளாஸ் ஆக்டிவிட்டி. சரியா ராஜா? கொஞ்சம் அது கொஞ்சம் பாசிட்டிவா பார்த்து அட்டெண்ட் பண்ணுங்க.
யார் யாரு ஸ்பெஷல் கிளாஸ்ல இருக்கீங்கன்னு ஒரு வாட்டி லிஸ்ட் பாத்துக்கோங்க. யுவர் நேம் இட் வில் பி யோர் நேம் அண்ட் ரோல் நம்பர் வில் பி ஹியர் வித் மார்க்ஸ். ஓகே.
अभी बालाजी, अरुणाचलेश्वर, बालकार्ती, भुवनेश्वर, भुवनेश्वर टी, दर्शन, धनशेखर, गौतम, हरिकृष्णन, हेमंत कुमार, जोयल, ज्योति शंकर, कामराज, कार्तिकेयन, कदिरवन, कृष्ण कुमार, कुमरवेल, लीनस पाल, लोकेश जी, मनोज यस, मनोज कुमार, मुकेश, नंदकुमार, नवीन प्रभाकरन, दिल्ली बालाजी, அப்புறம் கணேஷ் குமார் ஈ, பதிஸ் அப்படியே ஸ்க்ரோல் பண்றீங்களா?
பாருங்க சார்.
அப்படியே ரீட் அவுட் பண்ணிடலாம்.
निर्मल गांधी, प्रणव, प्रवीण राज, रुकेश, रूपेंद्र धनुष, सबरीश, संजय, शरत, சரவண சரண், சுடலை, தமிழரசன், தாமரை செல்வன், திருநாவுக்கரசு, வினோத், விஷால், யுகேந்தர், யுவனேஷ் அண்ட் பிரசன்ன வெங்கடேஷ். அண்ட் ஒன் மோர் திங், லலித் ஸ்ரீராம். இதுல பாத்தீங்கன்னா இந்த லிஸ்ட்ல பாத்தீங்கன்னா 47 பாத்தீங்கன்னா ஒரு அரௌண்ட் 8 to 10 மெம்பர்ஸ் இருக்கீங்க. ஓகே. இந்த 8 to 10 மெம்பர்ஸ் வந்து ஒரு 47 இன்னும் ஒரே ஒரு கொஸ்டின் எக்ஸ்ட்ரா அட்டென்ட் பண்ணிருந்தீங்கன்னா, கரெக்டா அட்டென்ட் பண்ணிருந்தீங்கன்னா there is no special class for you. ஓகே. ஆனா கொஞ்சம் கேர் எடுத்து பண்ணுங்க நெக்ஸ்ட் டைம். ஓகே. இட் மஸ்ட் பி ரெடியூஸ் டு 10% இருக்கணும். இப்போ 50% இருக்கு ஸ்பெஷல் கிளாஸோட ஸ்ட்ரென்த். ஐ நீட் 10%. ஓகே. 90% பாஸ் பர்சன்டேஜ் இருக்கணும் உங்களோட பாஸ் பர்சன்டேஜ். ஓகேவா? எனி டவுட்ஸ் இன் த கிளாஸஸ் from today classes for you? You can raise the questions now. Almost yeah, சொல்லுமா சூர்யா?
இல்ல சார், நோ சார், சொல்லுங்க சார்.
ஓகே ஓகேப்பா. சரி, meet you at 12:30. Thank you students.